-1 to the n plus 1, 3/4 to the n. Sure? Everything is exponential. But you include this other n or another k, it's not geometric. Well, let's try the ratio test, because does anybody know how to integrate this? If you're trying, I'll do integral tests, right? And you got a mixture of an exponential with a monomial. Does that make sense? Great test to use. So let's try it. What do we got to substitute? K plus 1, 3/4 to the K plus 1. Sometimes on a test people get lost and it's all they write. What did I forget? Wait a minute, it's a ratio. It's the a sub n plus 1 over the a sub n. So that's all I did was the a sub n plus 1. Divided by, I'll put my bars. If everything's positive, you can remove those bars. Sometimes you get the -1 to the n thing. What do I get now? K. 3/4 of K. Okay. There we go. Now, how do you simplify that? That's 3/4 of the K times a 3/4. I was about to race. I worry I raced that. Someone was still cocky, didn't see. I'm just going to write it again. K, 3/4. K, 3/4 of K. What cancels? Anybody, oh, I keep writing n. This is a variable k, right? I'll make that a k. I'll make this a k. Just because I had a k. You can use k. What's the limit as k approaches infinity of? Help me out here. Make sure I write everything down that's left over. I see there's a k plus 1 and a k. Anything else?
3/4.
Don't forget about that 3/4, right? See, if my eyes miss that, I think the limit's 1. And I'm going to say the test isn't conclusive. That 3/4 is there. I'll put it way out front. What's that limit? It's going to 1. 3/4 times 1 is what? 3/4. You can do L'Hopital's rule or think of the horizontal asymptote on this thing. Is this greater than 1 or less than 1? Converges by what? RT. Yeah. Converges by ratio test. Hey, we're going to do another one, but I want to put something down with this problem real quick. What if you had this? Whoop whoop. What's going to happen way at the end? Whoop whoop. Which would equal what? Whoop whoop. And that is now what? And what's the answer? Diverges. Someone see that? I mean, just a slight change in that, we see that. That's what we'll run through the whole test. All right, this problem, I'm going to find something that has like a -1 in there, -1 to the n. So it has a 2n plus 1. Okay. This one's busy. And when this is light number 13. There's a -1 to the n. It starts at n equal to 1. It's got a 10 to the n. It's got an n plus 1 and a 4 to the 2n plus 1. My goodness. Oh, we'll get it. Okay, does anybody know how to integrate this? All right. Is that a geometric series? No, no way. You got exponentials mixed with n plus 1s. Let's try the ratio test. All right, what's the limit as n approaches infinity of? That becomes -1 raised to the what? N plus 1? That's 10 to the? What's 10 to the n plus 1 become? 10 to the n times a 10. Can I start writing it like that now? Good. What's this become? N plus 1 is? Now help me out here. 4 to the, you need to substitute n plus 1 right there. And you got to distribute that 2. So what would be 4 to the 2, substitute an n plus 1, and you got a plus 1. What is all that? What does that become? People just think you always add 1, you always add 1. Well, not in this case. If I substitute an n plus 1 for that n, I got to distribute the 2. 2 times n plus 1 is 2n plus 2, plus a 1 is? Say again?
Right here, 4 is 2n plus 1, so 1 would be 2 times 1 plus 1. And you back up with
You're asking about here?
2. No, no. 4.
The original problem?
Yeah.
You wanted to do what?
You backed up with 2, like you did over there.
You're factoring?
Did you not back up with 2? Plug it in, plus 1. Okay. Oh, yeah.
This was the original problem.
Okay.
And what we do is we substitute n plus 1 for n.
Okay.
We substitute n plus 1 for that. All right. Now, what do I have to divide it by? That's a sub n plus 1, isn't it? Yeah. You got to divide by a sub n. What's a sub n? Just everything I have. Now here, right here, I'm going to write down the original expression. You got 10 to the n. What else you got? n plus 1. And you have 4 to the 2n plus 1. Now, what are these absolute value bars going to do that negative 1 to the n plus 1? It's going to make those negatives go away. Does that make sense? What's negative 1 to any power? You know, it's either a negative or a positive, but the absolute value bar is just going to make that positive. And we're going to flip this upside down and cancel stuff out. True? All right. And we'll see what we get. Goes that approach today. You got negative 1 to the n. Can I write this as negative 1 to the n times negative 1? Then you got a 10 to the n times a 10. All over n plus 2. This would be 4 to the 2n times 4 to the third, right? Does everyone get how I wrote that? Awesome. Dot, now what goes upstairs, and I'll flip this other thing. I've got an n plus 1 upstairs. I got a 4 to the 2n. That'd be 4 to the 2n times a 4. And this is all over. A negative 1 to the n and a 10 to the n. And I'll put these bars. We've got our bars right there. What cancels? Boy, a lot cancels. Can we start with the 4 to the 2 n's? Oh, kind of question.
Yeah. If we take off the bars, can we just write it as 1 instead of negative 1?
You sure can.
Okay.
You can do it right away. Because that's all it's there for. You're like, oh, it's just going to make those negative 1s go away. You can ignore this from here on out. So he's saying that when he's like, this is going to cancel this, but he knows the x value negative 1 is just a 1, he's going to go right to that. Connor's doing 2 steps at once. It's a good idea. What else cancels? 4 to 2 n's go away. 10 of the n's go out. What do we have remaining? Remember, the absolute value of negative 1 is a what? A 1. So what's remaining? Come on, we got this. This problem looked intimidating. We got this. You got a 10 left over, what else? The 4, what's 10 times 4?
40.
You got a 10, you got to multiply a 4, what's left in the denominator? 4 cubed? Anything else left? What is 4 cubed? 64. Anything else left over? Keep looking. Ah, the n plus 2 is still there, right? Okay. Let me write that again. What is that? 40 over 64 times n plus 2. Oh, that was n plus 1?
Both ones.
Oh, the n plus 1's up there too, very good. What's that limit?
5/8.
40 over 64. Reduced to 5/8. Is this greater than 1 or less than 1? Less than 1. 40 over 64 is less than 1. This converges by what? RT. John? Any of the weird ones with the factorial? Okay, last one, number 3. But I'm not going to raise till everyone has this. Hey, Connor's suggestion, Connor likes this. Others may do this. Remember how we're going to keep putting these bars down? That -1 to the nth is just going to make it a positive 1. He goes, he can eliminate that right away. If it's, it saves writing. Some of you might do 2 steps at once when you see that's for the 2n times 4 cubed. And Nicholas, you were fine with that substitution. That's the only weird thing. It's going to happen again on this problem. Because that's why I wanted to make sure. If I didn't show one of these examples, Nicholas, what happens with students, they think in the ratio test you just always add 1. Where we really substitute a m plus 1 for each n. All right, here's the last one. This is an even problem. This is number 6 from the test. And this is what they have. Does this series converge or does this diverge? N equals 0, go to infinity. Ah, it's starting at 0. Negative 3 to the n, 2n plus 1 factorial. All right, let's go through the list here. Can I use geometric series test? No, that's out. Right, everyone? Geometric series test? That's out. How about test for divergence? How about the test for divergence? Can I do it? No. Limit's equal to 0 of the sequence. Are we agree? How about integral test? Can I use integral test? Integrate with the factorial? No, that's not working. Well, what's a great test to use? It's got a mixture of factorials and exponential. Let's try the awesome ratio test. Okay, so we do the limit. Then it approaches infinity. Negative 3 to the n plus 1. All over. I need some help. Hopefully Nicholas will help me with this. Oh, wait, I'll wait till you're done running. I gotta substitute an n plus 1 in there. 2 times, right, he goes 2 times parentheses m plus 1 plus a 1. That's what that means, with the factorial. Someone see that? This is what this means. I'm thinking of all this, and it's a factorial. Well, what is all that? It means I gotta substitute m plus 1 for that n, and then distribute the 2. 2n plus a 2 plus a 1 becomes 2n plus 3. Okay with that? Yeah? So I'm going to rewrite this as 2n plus 3 with the factorial. Unless someone wanted to write it like that in their notes. Did anybody want to write it like that in their notes? No? Okay, I'm going to write that as 2n plus 3 factorial. All right, that's 2n plus 3 factorial. Excellent. All right, we're rocking and rolling. Everyone put the fraction bar. Now what? Oh, the original. Factorial. Hey, put the bars. Put my equal sign. Limit as n goes to infinity. That's negative 3 to the n times the negative 3. All over 2n plus 3 factorial. Absolute value bars. I'm going to flip the bottom. 2n plus 1 factorial. Negative 3 to the n. So what cancels? The negative 3 to the n's go out. What's the absolute value of a negative 3? 3. here's the part you need to help me out with. How do I simplify that? How do I simplify 2n plus 1 factorial all over 2n plus 3 parentheses factorial? Well, do you notice something? This denominator is 2n plus 3. What's one less than that? 2n plus 2. What's one less than that? 2n plus 1, etc. And what will cancel? Everything afterwards will cancel out except for the 1 over 2n plus 3, 2n plus 2. So let me write this again. This is what we have now. I'm taking off the bars, and we're going to have this answer. We have a positive 3, because the absolute value of negative 3 is 3. All over, let me write this. 2n plus 3 and 2n plus 2. n plus 3, 2n plus 2. And what do you get there? What's that limit? 0. Can I use a ratio test when you get a limit of 0? Yes, you can. That's throwing people off sometimes. They go, they got to equal 0, and they go, I guess I can't use a ratio test. Of course you can. That limit is less than what? 0 is less than 1. Right? This series converges. Converges by the ratio test. I'll just put R. Woohoo! Super job, everyone. And we covered everything, even the weird 2n plus 1s and 2n plus 3. And thanks for bearing with the heat. Oh, it's hot, my chalk's breaking all over the place. Super job, everyone. Hey, keep in mind, section 11.7 is just a summary section where they just throw a bunch of problems at you. I picked some to practice. And you go in there and you're like, which test am I going to use? You can check the back to see if you get it right. Keep in mind, sometimes there's more than one test, right?
How many questions is this test?
This test